Okay, welcome to the next day. Okay, before we start this one, I nearly forgot that I had these things, so give me 1 second. Okay, here we go. I pull these out occasionally, sort of for fun. Okay, so let's see. This one. Okay. Give me a second. Okay, just make sure everything is working. So sometimes I use these ones just for some fun little quizzes at the end. Sorry, I don't know how to make that QR code any bigger, but yeah, go ahead and scan that and join in. This is about the stuff actually from about 2 lectures ago. I forgot I had this one. I know I've got them going forward, just I didn't know I had the older ones. So while we're waiting for people, go ahead and join. I think I can only host about 40 people anyway. It's always a strange thing. Does the sound work? Do we even want to hear the sound? Okay, you can use my name as fine, but you have to be at the top when you're finished. Otherwise, I'll track down whoever's done this. Okay, we'll start this one. So if you didn't get in, no problem. There'll be many of these. Normally I stick them at the end of class, but this one is just because we already went through this. So here we go. Start. All right, so it's all about types. It's actually stuff that we've done already. So hopefully I've given enough time on these. Sometimes I give something just a little bit too short of a time. Most of the time they appear as what's the output of this. Okay, so in this case it's how many lines appear. So it's 1, 2, 3, 4, 5, 6, 7 lines. Looks like no, wait a second. The correct answer was 4, and only 3 people answered. Everybody went for the wrong number. Okay, now, sometimes it happens that I make a mistake on this, so let's go back and double check what the actual answer was. So how many lines? So we're talking about how many different lines would show up. Okay, on line number 3, there's a print statement. That'll be 1 line. Okay, then there will be a print laptops. Okay, that's fine. The next one will be print laptops but because it's got the end, the next line does not count. Then there'll be 1 more, so 4. Okay, yeah. I do this for a couple of reasons. Remember, when you hit these MCQs in the labs and even on the midterm, people say, yeah, it's a trick question. No, it's an understanding to make sure you can actually see what's going to happen. Because if you can't look at this and say, how come I'm seeing 4 lines instead of 5, you have to be able to justify this, okay? Because these are the tricky things that do catch people. All right, so here we go. Move on to this one. Okay, so the user types 41, and 1 is the inputs to this program. So what's the output? So remember, 41 and 1. Oh, good. The biggest bulk of people ended up on the correct answer this time. A bunch of people went for the number 42 because, of course, 41 plus 1 is 42, but unfortunately you have to remember that inputs always return strings. Okay, and if you take 2 strings and add them together, you get string concatenation. So it would be 411. Okay, that's why it comes up as 411. Okay, next. Okay. So this one, simply, what is the output of this program? Surely this has got to be quite simple. Okay, you can use a calculator if you have to. And the good news is more people answered it correctly than not. Let's see, what did we catch people with? Some people said that there was 20 in total. Some people said there are curly braces total computers in total. All right, good. So the people who picked blue, of course, realized that, hey, yeah, there's no F here. Yeah, of course, that would happen. The issue happens on line number 2. Okay, line number 1 sets laptops equal to 12. That's no problem. Line number 2 calculates laptops plus desktops, and the thing is, we have no idea what the value of desktops is, so that ends up with a program that basically executes a runtime error and nothing else happens. So that's why this one ended up being the answer. Okay, here we go. Next one, and then we can see who's ended up at the top. So what variable should be used to store this input? So you're going to ask the user, how many students are there in this course? This one's pretty straightforward. And by the way, all of these would work in Python, but they won't work in this course. Well, they should work in this course. Please let me know if you use the wrong format and the lab instructor gives you grades. Let me know so I can reduce your grades. Okay, Python uses snake case format. Okay, good. Okay, so no total students with a capital T and a capital S. That's actually a class name, so please don't use that. Okay, so here we go. You can see who ends up winning. Put this away and start the real stuff. So A, it better be me. It works in Python. It does not work in this course. Okay? In this course, we follow PEP 8 standards. The standards are standards. They're supposed to be used across every Python program in the planet, providing people are following them. We use different styles to represent different things because there are no types. So, for example, if I said tree house, what this is, that's a variable. Okay? If I say tree house, that's something called a class. Okay? If I said tree house this way, that's a variable in a different programming language. And if I said tree house like this, that's actually a constant. Okay, so these are standard values or standard formats that everybody does agree with. And although your programs work, you will lose marks. So your choice if you want to lose marks. And then you can argue and say that it works, and then the instructor will show you the grading scheme, and you still won't get your marks. All right, so yeah, this is one of these lines where things work I wish they didn't, but things do work. All right, on to the real lecture for today. All right, as I said in the news item, yes, I am keenly aware that everybody's covered loops. There's probably only one or two very minor things that you haven't seen before. However, I find that usually in 1201, it's been some time since people have taken 1101, that they have forgotten some stuff. So we consider this kind of a reminder because these are types of programming patterns that happen over and over and over again. And this is really where things start to become, well, a little more challenging. You see, even in INFS 1101, the first types of programs where you ask the user for input, do some calculations, do some output, nobody ever has a problem with this, okay, once you figure out the syntax. If statements, not too bad, because really at this point it's just logic. You want to check this value, and if this condition or this condition is true, then you do something. That's easy. When you get into loops, we're talking about repeating the same piece of code over and over again, which is okay for an understanding, but to be able to come up with one on your own requires significant amounts of pattern recognition to figure out what happens before the loop, what happens in the loop, what happens after the loop, and are there things inside the loop that sometimes happen and sometimes don't. This is the hard part, okay? This is all about pattern recognition. That's why they attempted to talk about pattern recognition in INFS 1101. Okay, so we will be talking about the while loop today. There is another form of loop that we will talk about in 2 days' time. I include this one here just as a reminder, because usually by this time I have everything settled. It's almost settled. So just to remind you, there are 3 major assessments that happen outside the regular lab period. Okay, so labs and quizzes, they happen during the lab period. There are 3 things that happen outside of the lab period. The first is the midterm exam. I've got a date picked for it. Okay, so there's a 1-week break, the mid-semester break. It won't be that weekend, but it will be the next weekend. So what we do is you go on break. Good. You come back, we'll do a review. Nice. And then you'll have the midterm, unfortunately, Saturday morning. Now, I've noticed here it says so that all students have the same level of difficulty. Oops. Actually, so all students have the same level of difficulty problems. Sorry, it's not meant that you will have difficulty. But this way, all the problems are the same. Sorry, I've said it before. I don't like to drag people in because it's not only you, it's me, it's the instructors. But it's the only way to make sure that everything is fair so that everybody gets the same problems. The last thing I want is for one section to get an easy problem and another section to get a difficult problem. That is a really big trouble. That is more trouble than bringing somebody in on a Saturday. All right, so that one is fixed. Okay, I will post a news announcement once I sort of get it confirmed, but I think I saw a message saying it's done. So whatever I put in the syllabus should be good. About 3 or 4 weeks later, there's also a lab exam. Happens the same thing. It'll be a Saturday morning. Final exam. This is the registrar's office to pick this one. I will post something into D2LSD announcements probably this week, and I'll include as part of that. All right, so if loops are so difficult, why do we need them? Because if you didn't have them, you'd be literally copying and pasting a whole pile of code over and over and over again. Think about this tool right here, PowerPoint. I mean, what do we do? Okay, well, we show a slide. Well, eventually what I do is I press the next key, and that gives me the next slide. And guess what it does? It does the same piece of code again. It shows the next slide, and it shows the next slide. If we didn't have a loop, what would happen is the people who made Excel would have to copy and paste the code over and over and over again. And the question becomes is how many times? Well, I mean, for this set, I only need to copy and paste it 17 times. However, you know very well that there are some slideshows that go on for a lot longer than 17 pages. So how do you deal with this in a general case? Well, you write the code once and you simply repeat it until, well, I press the escape button to stop it. So although you could almost get away without having loops, the programs you would write would not be very interesting. Okay. Let's toss this out of the way because this is one of these things where I think the code will make a lot more sense, and again, we can try various things. Once I find a cursor, here we go. So, yes, we learned in INFS 1101 something called a while loop. Okay. All right, to remind you what this looks like, I've got a very simple little app. I've got the same app that I'm going to use here. I initialized a value called, a variable called value. This program, by the way, doesn't do anything. It's not very exciting. And what I'm doing is I'm saying, well, the value does not equal to -1. Okay, I'm just going to say start off loop body, and I'm going to say value is equal to an integer input. So remember, you're typecasting these things. I'm just going to say next value, and I'm going to say print end of loop body. And I'm going to put a couple of extra print statements in here as well. I'm going to say before loop body. Okay, and this very final one down here, I'm going to say after loop body. Okay, there we go. There's the main overall structure. It's the same picture I've got over here in the slides. All right, here's the way how the whole loop operation works. All of the stuff up before the loop just continues as normal. Yeah, we do a regular sequential programming. There's no if statements in here. Everything just continues. So if I were to be able to see what's going on inside this program, the very first thing that would happen is line number 1. Pretty straightforward. After line number 1 would come line number 2. Okay, that's pretty easy. And after line number 2 comes line number, okay, you guessed it, 3. All right. Line number 3 is kind of like an if statement. Okay, in fact, you could think about it this way for a second. Okay, if the value is not equal to -1. Okay, so yeah, a little bit of a weird stuff because now I've got 2 negatives, so double negative. So basically, if the value is not equal to -1, then you do the next 3 lines. And if it is equal to -1, then you don't do anything. Okay, well, how much is value when I reach line number 3? 0. So is that not equal to -1? And that condition is true. Okay, so if I were to run this program as it is right now, it's going to show before the loop body, but because that condition is true, I'm going to do the stuff inside. And now, of course, I've got an input, so I'll just type in a number. Doesn't matter. Program doesn't do anything. We'll actually solve some real problems in like next couple of slides. This is just to remind you of the syntax. After I press enter, this, of course, everything is blocked on line number 5. We will do line number 6, which says end of the loop body. I know it's not a loop right now. And then we continue on with the rest of the program. Okay, so when we press enter here, end of loop body, after loop body, okay, everything is fine. When you take something and turn it from an if to a while, things change up a little bit. It's kind of like an if statement, except that once the person puts in the value on line 5, we will continue and we will do line number 6. So we will see end of loop body. But then what happens is we immediately go back up to the condition once again. We go back to line number 3 and we ask, is the value not equal to -1? And if that condition is still true, then I go back and I run the whole thing again. So, for example, if I type number 12 here, it continues that it continues that loop body, goes back up and it asks again. And no matter what I type in, it's going to be doing exactly the same thing until I suddenly hit -1. So right now, the whole program is stopped on line number 5. It's waiting for me. I'm about to type in -1. After I type in -1, this statement still happens. Once you start the loop body, you continue the loop body right to the end. And it doesn't matter if you don't want to or not, you continue until the end. So if there's only one statement, only one thing happens. If there's 50 statements, 50 things happen. But eventually what will happen is I will go back up to the loop and I will check the condition. This time, after putting in a -1, that condition will be false, and that is what will terminate the program. Okay, now, very important, you know there's stuff that happens before, you know there's stuff that happens during, at the beginning of the body and end of the body, and you know there's stuff that happens after the loop is completely finished. Okay, the usual picture that shows up is a little piece of flow chart I've stuck in the lower right-hand corner. You enter the loop, you do some kind of a check. If the condition is true, you do the loop body, but you'll notice that you always go back up to the top. Okay, you always go back up to the top, and you make a decision, do I do the loop body again or not? Something that's very important, it doesn't matter how many statements you put in here, everything is done. So even if you put in -1, the rest of the loop body continues. And sometimes that can be a little surprising because sometimes I end up with students who think, hey, as soon as you print something like this, there we go, I'm going to print an A, I'm going to print a B, and I'm going to run this time right here. Which line is my program currently stuck on? 5. Okay, if I put in a -1, here's the question. Do I see the output on lines 6, 7, 8, or not?
Yes.
And the answer is yes, because I'm inside. Okay? Of course, I have to press the right button. There you go. So yes, I do see it because I've already started. Okay, once you started, you have to finish it. Unless you got some other things, which we'll cover in a few minutes. Okay, this one is just a slide to talk about things, and then there will be an example. All right, in the world of loops, in the world of programming, I think maybe it's not as covered as much as what I would hope it was covered in 1101. So this is definitely the reason why I include this. All right, there are basically two forms of loops. We just saw one form, which by the way is not a counted loop. We'll see that in a few seconds. But we have a type of loop where you know in advance how many times the loop is going to execute. These are really, really good for questions that start with ask the user to enter 10 of something. Go through each character in a string. It makes a really, really good counted loop. Okay, so what we're going to do is let's write a program. Okay, let me see what program I've got coming up here. Okay, multi-line strings. Sometimes I use them as comments. Okay, so here's a comment. Ask the user to enter 10 test scores and find out how many scores were passes. Okay, it's the usual typical thing. It's what I've got written right here. All right, so ask the user for 10 scores. Okay, input, copy, paste 9 times. No. Okay, yes, it will work, but unfortunately, if I do something like oops, not like that. If I do something like that, you don't want to copy and paste something 9,999 times. I have a pretty simple rule in most of my programming classes that say, okay, you copy and paste something once, it's probably okay. You copy and paste twice, you have to look at it because maybe there's a better way of doing it. If you copy and paste it 3 times, you're definitely doing it wrong. Okay, something that's copied and pasted 3 times probably means that it was a pattern, and you've changed some variables. Figure out what the pattern is, use a loop, do it 3 times, or better yet, use a function. All right, so yes, I could do a pile of input, but let's not do it this way. Okay, we'll fill this out. Now, the way how I write programs is often very, very different than the way how I'm going to describe it as an intro programmer ends up writing programs. And the reason for it is because, well, I've got the experience that I tend to do things in a certain way because I don't like to fail. Now, I don't know, maybe you guys enjoy failing, and I don't mean failing the course. I mean just not getting your programs to work. Okay? Programming is less about just knowing exactly what to type, and it has more to do with the process how to get there. All right, so what do we need? We need a loop that happens 10 times. Well, you know what? Start with that. Don't ask the user for anything. Don't count tests. Just print out 10 things in a loop, of course. All right, to deal with the counted loop, we always have some kind of a loop counter. All right, so here's what we're going to do. We're going to have a test number. Most of the time, and I will come back and we'll adjust some of these in a few seconds. Most of the time, we would end up with a test number being equal to 0. You know what? Test number 1 for right now. All right, we have some kind of a loop. There's always a condition. What is it? I don't know, just placeholder. We'll fix this out in a second. Here's what I'm going to do. This is the test. Okay, nothing else. We get this much to work. Now, the problem is what do I put as those question marks? Well, we need to do this because we need to repeat something over and over again. This test number is actually going to be what I call the loop counter. So the way how we deal with a loop counter is we initialize it to something. A 1 works. 0 is better. We'll talk about that in a second. But a 1 really works. And what we're going to do is we're going to put in as our condition to say that if the test number is less than 10, we're going to print this. But of course, if I run this right now, the test number is equal to 1. So it's going to say this is the test. And it's going to go back and it's going to check what's the value of test number, still 1. And it's going to run it again. And it's going to run it again. And it's going to run it again. And, okay, I better warn you about this. All right, if you do this, it will happen. Please hit terminate. If you let this thing run for like 2 or 3 seconds, it'll crash the browser. You can see that it's already crashed a little bit. If it crashes, just reload and you should get back the same code you just had. Okay, so that's just about our interpreter. So if you make an infinite loop, oh, by the way, that is an infinite loop. It's covered in the slides later. And sometimes you do want an infinite loops, but I don't think we want to print out this is a test, this is a test, this is a test, because we only want it to happen 10 times. Something that's very, very important. You need to have a loop counter. So it's a separate variable. Don't use it for anything else. Okay, you can use it to look at it. You can use it for computation, but don't change it. You come in here and you set up, say, while it's less than something, and you always have to remember to do, well, some kind of an increment. So I will write it this way this time. Okay, test number is equal to test number plus 1. So here we go. So test number becomes test number plus 1, means the first time through it's a 1, second time through it's a 0, next time through it's a 3, then a 4, then a 5. Excellent. All right, so, hey, did it print 10 times? So some people said yes, but yeah, oh, it's only 9 times. Yeah. Ooh, okay. So I have a couple of ways how I can solve this problem. Okay, and this is why I've done it this way. Thank you for asking the question. You see, the way how it works is we go through it once when it's 1, then when we check again, you say, okay, now it's 2, do I go? And the answer is yes. When it becomes 9, there we go, there's 9. If it becomes 9, is 9 less than 10? The answer is yes, so it goes in and prints it the 9th time, but then it becomes 10, and the final check, it says, well, is it less than 10? And it isn't, so it doesn't print the 10th time. So there are 2 solutions to this. The first solution is, oh, you know what, this might be kind of fun, because this actually becomes, so this is test number. Okay, here we go, let's run that. So test number 1, 2, 3, 4, 5, 6, 7, 8, 9. Excellent. All right, what can we do? Well, I've got 2 solutions to this. Less than or equal to. Because now it will go for the final iteration. That will provide me with all 10. All right, this is a possible solution. Is it a solution that most programmers would pick? And the answer is no, not really. Okay, why? Okay, I know that you start counting. Okay, if I ask you to count to 10, where are you going to start? 1. Computers don't start counting at 1. They usually start counting at 0. Why? Think about the strings. If you want the first character in a string, it's at position 0. Most people who write programs will end up using 0. So instead, exactly what was just asked is maybe we should have started from 0. Okay. When you run the program, now it says, oh, test number is 0. Okay, we'll deal with this in a second, but now I've got now I've got a new problem. How many times did it display? Yeah, now it's got 1 too many. Again, 1 less. Okay, so just ignore the very last item. Here you go. Now it's 10 items. That's what we want. The only thing that's kind of a bit weird is the users don't like to see this. Computers like it because if I had a bunch of tests in a list, which eventually we will get, the very first test is at position 0, just like the characters in the string start at position 0. This is the way how a computer likes to work, but it's not the way we like to work. Yeah?
If I put less than 11.
If we put less than 11, then what it's... Oh, exactly the same thing. Less than or equal to 10, less than 11, same because they're integers. Okay? All right, so what we need right now, however, is start something from 0 because we're going to need it. Okay? Even though we don't need it for this one, we will need it when we hit lists. And we'll repeat this with a string in a few seconds so we can see the individual characters. All right, so here we go. This is test number 0. It's test number 1. Well, most people don't like talking about test 0. I'd rather talk about the first test. All right, so how do we do it? Okay, change it to 1. Go less than or equal to 10 or less than 11. That's one way. This is a very, very common thing is, well, when you use the curly braces in a print statement, that's not an assignment statement. Okay? It does not change the value of test number. All that you're doing is say, go and find the value of test number and add 1 to it. That is the way that's probably preferred. So this kind of gives the best of both worlds. It allows the user to see what you want to show them, and it also keeps it 0-based because, well, that's really what your lists are going to want a little bit better, or a little bit later. This is what I want, okay? And this is a very typical thing. So I start at 0 and I say less than a number of times. This is always the way you're going to see me write loops. I won't write them any other way. I'm going to write different types of loops other ways, but whenever I write a loop, I will almost always write it starting from 0, and I will go less than the value, because it matches up well with list indexes and character string indexes. That's the reason for it. All right, we don't want to print the message. We want to ask the user for the message. Okay, so to ask the user, we have to ask for 10 test scores. All right, so let's call it test score. All right, test scores are probably integers. They could be floats, doesn't really matter. And I'm going to say enter test number. Oh, test number. Okay, unfortunately, this is going to go off the edge a little bit. For it to appear, yeah, it works just like this. All right, test number. Oh, no, not that. +1. All right, here we go. Enter test number 1. Okay, here we go. Just a bunch of test numbers. I don't even care what they are. That's too much of a test. All right. That's nobody's test score. All right. The good news is the program stopped. And that's an important thing, because if you can't get a program to stop, there's no reason to solve any other problems. Have I solved the problem to find out how many scores were passes? No, but I don't care. At least I got a basic program working. Okay. So sorry, that's kind of gone off the edge a little bit, but I've at least got a basic program working. Is it important that I keep asking for 10 every time? No, let's be a little bit lazier. 5 will be enough. Okay, let's just have 5. Because in the end, I mean, you could change to whatever number you want and it should still work. So I would like to be a little bit lazy. During your labs, please be lazy. And I don't mean lazy by going to ChatGPT. If you have to ask the user to enter a whole bunch of stuff, well, reduce the number of stuff. You don't need to type a whole pile of numbers every time. Once it's done, then finally do your final check at the end. All right, so ask 5. Ask 5 times. It was working for 10, should still work for 5. We are to count, oh, here we go, how many scores were actual passes. All right, so here's what I'm going to do. I've got a loop counter. Put a little bit of space over here. I don't like being jammed up so close. All right, let's just run a quick scenario. Okay, we already know that there's a counter for counting the number of tests. Well, sorry, the test number. Now what I'm going to do is I have to count how many things we have as actual passes. All right, so if somebody comes along and the very first score is 80, is that a pass? Okay, so here's what I'm going to do. I'm going to raise this finger. Okay, here we go. That's a pass. All right, another person comes along. There's a 67. Is that a pass? Yeah, passes are bigger than 60. Okay, 60 or more gives you a pass. Okay, yes, I know it should be more. I would be quite happy if the pass was about 80 or 90, but you guys wouldn't. All right, so here we go. Is that a pass? And the answer is yes. So what am I going to do? I can raise another finger. Okay. Somebody else comes along and get a 34. Is that a pass? And the answer is no. So do I lower finger? No, just leave it as it is. All right, so in other words, every time that I find a number that's 60 or bigger, I'm just going to raise another finger. So here we go, and 80, there we go. Pretty good pass rate. We've got 4 people out of 5 who passed. Excellent. All right, now in order to count things, it's always the same pattern over and over. Yes?
We did before test, but without the +1. And it's work.
It worked, but it was showing zeros. I stopped it right away and put a +1. Okay.
Should be +1.
It depends on what you want to show. If you want to show the user enter test 0, enter test 1, it's okay. But if you want to show test 1, test 2, test 3, which most people would want, add the 1. Okay? Okay, so here we go. Now I just need to replicate this. This, of course, is called a variable. Okay, so I'm going to have an extra variable over here. It's going to be called pass count. Oh, can it be called pass? And the answer is no. That's a nice reminder. That means something very, very different. I'm going to have a pass count or a pass counter. I'm going to initialize it to be 0 because that's how many I've seen so far that have passed. As soon as I enter this number, okay, sorry about this. This is the problem about having too big of a font. I am now going to make a question. Okay, if the test score is bigger than or equal to 60, put it up by 1. And of course, that is an abbreviation to say pass counter is equal to pass counter plus 1. Okay, I'll use this shortcut quite a bit. I will normally use it for this one as well. Okay. Finally, of course, what we want to do is at the very end, after all of the data has been collected, well, then you want to print something. All right. Most of the time, I'm not going to print out full sentences. There were, blah, 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 and I will just include pass counter, blah, 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 blah. Okay, yeah, write it out in a full sentence. For here, just in order to fit, and in terms of timelines, I will probably abbreviate a lot of my output messages. All right, that print statement happens only at the very end after everything has been done. So here we go. We've got a 70, we've got a 30, we've got a 40, we've got a 12. Okay, maybe it's giving a bad impression about this course. Not that it needs any more. All right, and a 100. How many of these will be passes? 4? Wishful thinking. Yeah, I only see 3. Okay, so there are 3. Okay, perfect. All right, there you go. Counted loop. The fact that we have something as a loop. Take a look at this. I'm going to mark a couple of things. I'm just going to put some hashtags just so I can talk about it. The number of hashtags doesn't mean anything. I just want to be able to identify these things right here. Those 3 lines are the pattern. Okay? People are always talking about, yeah, you know, programming is really difficult because I can't memorize things. There's something you can memorize. Memorize the patterns. By patterns, I mean these are things that keep appearing over and over again. It doesn't matter if you're asking for 5 test scores or 50 test scores. It doesn't matter if you're asking to count how many cats there are in a building. It doesn't matter what it is that you're doing. If you are asking the user to do something a certain number of times, that's exactly what it is. Hey, over here. All right. If I want to print this set of slides, sorry, the number is really, really small down here. I can zoom in maybe this way. How many slides are there? 17. You know that in advance. What are you going to do? If I were writing the code to print this thing, what I would do is I would now say, okay, generate 17. I'd set up a loop for 17 times. And I'd have for pages equal to 0, while page is less than 17. I'll go this direction. And at the very end, it'll say page is equal to page plus 1. Yeah, the code will be there. Okay. Well, if they stored it that way. Probably not. Okay. But the same pattern keeps appearing over and over and over again. We'll be using a lot of counted loops. Luckily, because we use so many counted loops, there's something that will help us a little bit. All right, the next type of loop, we actually saw a second ago. It's called a sentinel loop, and this is a loop where you stop because you encountered a condition that said, hey, we're supposed to stop at this point. The classical example shows up in INFSC 1101 and the intro part of 1201 in the following format. Have the user do something until they type quit. Have the user do something over and over until they put in -1. Look through a bunch of characters of a string until you find a question mark. These are all sentinel-based loops. So you don't know how many times it's actually going to happen, but instead you go until the user says, yeah, unless I've had enough. Okay, so what are we talking about here? Let's change up my program a little bit. Oh, and notice the way I did this. Did I write the entire code from beginning to end and said, voila, look at that, the whole thing ran? And the answer is no. I developed it little bits at a time. And you'll notice that I didn't just do one line, next line, and okay, that works, add another line. I did it this way, but notice it was here, 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 here. Okay, yeah, this is the way how development works. Go and look at anybody who develops stuff. Anybody who tries to write everything from beginning to end is almost never successful. I can probably write about 30 or 40 lines of Python code, maybe, without having problems. But even simple things like this, I do it too. Okay, and you might say, what, just like 3 or 4 lines? At times, yes. If I think it's really, really difficult, I will do things. All right, let me write a new version. Okay, so for this, we'll get rid of this. So we're going to ask the user to enter test scores and find out how many scores were passes. There we go. There's a slight modification. It almost does the same thing. Okay? But the behavior of the algorithm has to be very, very different. It says here, ask the user to enter test scores. Actually, I suppose I should include repeatedly. And find out how many test scores were passes. The program will stop and report the number of passes only when they type -1. So there's a stopping condition. So I don't know how many students are going to write this test, so I'm just going to keep typing these things in until I run out of tests. All right. The pattern, the programming pattern, is quite different. I'm going to do the same way that I did last time. I'm not just going to write some big long piece of magic code and say, hey, maybe it'll end up working. I am going to put together a little bit of it and see if I can get some of this stuff. All right, first one up is how many times do we go through? Don't know, because it didn't say. It's going to be completely dependent on what the user did. We actually saw this a couple of minutes ago. Now, unfortunately, there's a few different ways how we can deal with this. I'm going to cover the classical way of doing this, and okay, if we get time, I will show you some alternative ways of doing this, and I'm going to suggest that maybe the classical way is a little bit better. Okay, I don't have a counter. Well, not yet. I might need one. But what I'm going to do is I'm just going to go out and I'm going to outright ask the user to input test score 1. Let me just put in enter test score. We'll talk about adding a counter to this later to maybe make it look a little bit better. All right, so here we go. That's the first thing. Now, obviously, if I run that program, it's pretty dull. Just asks for one thing, doesn't do anything with it. All right, but the thing is I'm supposed to do this. If the test score does not equal to -1, well, what I really want to do is I want to ask again. Okay, so take a look at this. The program is far from finished. But if I put a -1, you see the whole program finishes. It doesn't ask again. If I instead put like a 34, notice it asks again a second time. Okay, but of course now the next one's ignored because, well, I don't have a loop. And don't worry, we also have a crash. It's because I typed a Q. All right, so here's the issue is if I simply switch that if into a while, well, it'll repeat over and over and over again. So there we go, while. Okay, enter a test score, 67, yeah, keep asking, 98, that's good, 45, that's good. This one, -1, yeah, -1 makes the whole thing stop. Okay, this is the pattern for a Sentinel-based loop where you're asking the user for input. Even if you're not asking the user for input and you're pulling characters out of a string, it's still the same format. We'll have to change the conditions a little bit, but it's still the same format. You do something, and you say, well, the condition isn't true, you keep doing the thing over and over again. It has one very curious little property, and that is we have 2 inputs. And do we really need, can we get rid of the 2 inputs? We'll talk about that, but no, really you can't. All right, here's what I'm going to do. In here, I need to count whether or not something is a pass or a fail. Well, we had it a few seconds ago. We said if the test score is bigger than 60, I suppose make it bigger than or equal to 60. Here's what I'm going to do is I'm going to have the pass count is going to go up by 1, which means that, yeah, I need to have a pass count variable, and we'll start it off at 0. Okay, and right down here, and we'll print exactly the same thing. So blah 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 blah. There are this many passes, and we'll print out pass count. Okay, here we go. So is that it? And the answer is yeah. But you'll notice something very curious about where I put the if statement. I didn't put it just after the input. Actually, I did. You see, this if statement right here happened just after this input statement. And this, on the next time through, happens just after this one. So I actually have put it afterwards. We'll talk about switching this around in a few seconds. All right, let's find out. Okay, 70, 67, 12, 13, 14, all pretty low scores. So out of this mess, there's only 2 passes this time. If I put a -1, I mean, to stop the program before, does it report back correctly as being 2? And the answer is yes. Okay, and again, just put out a nice message here. All right, now at this point here, this, by the way, is the classical way how you structure a Sentinel-based loop. You check something at the beginning, and you check something just at the very end of the loop, which of course is just putting it just before the beginning. Almost immediately, somebody will say, well, wait a minute, can I get away with just a single input statement? So, you know what, let's look at it. Because usually a student in this course, or 1101, will say, well, how about if I just put it here instead? Instead of putting it, oops, sorry, removing too much, instead of here. Because, I mean, only do something once. All right, The problem with this is when I run it, what's the first thing that I see? Yeah, I see an error. Why? Remember, program starts from beginning to end. The very first thing that happens is I said pass count is equal to 0. Okay, that's fine. Next thing I do is I say, okay, is test score not equal to -1? And immediately I go, I have no idea what test score is. That's what it says right there. Test score is not defined. That's why you can't do it. All right, undoubtedly somebody else will come up and they'll say, okay, in that case, I'm going to be sneaky and I'm going to say test score is equal to 0. Okay, seems almost reasonable. So here we go, enter test score. Okay, perfect. All right, so here's a 60, here's a 70, here's an 80, here's a 12, and another 12, and a -1. How many passes were there? 3. Oh, hey, good, excellent. So therefore, all what I just told you is not actually needed. Actually, there's a bit of an issue. It's not visible in this program, but there is an issue. Okay, let's suppose that I don't only need the pass count, but I need the number of tests that were actually taken. So, test count. Okay, so this is how many tests I've got, this is how many were passed. So how many test numbers did I just put in? I put in 5. 3 of them are passes, but I need both of them because, well, it's a percentage thing. Trust me, at the end of midterms, somebody will come and they'll ask me how many students passed 1201. And I'll give them a number, then they'll say, but how many students were there? And of course you have to divide those two numbers. And that can sometimes be freaky or not, because if the number's too small or too big, everybody gets upset. Okay. Yeah, if the pass rate becomes really big, everybody's suspicious of me. All right, so we've got to be careful. No, we don't actually try to fail people, don't worry. But in any case, we might need to know the actual number of tests. All right, so at this point right here, somebody just entered a test. Very good. So what I'm going to do is I'm going to say test count goes up by 1. Okay, and I'll just print out test count as well. All right, and we're going to run this exactly the same. So we had a 89, 89, 89, a 12, and a 12. That's good enough, and a -1. You'll notice that the pass count is correct, but the number of tests was off by 1. Okay, and the reason why it was off by 1 is because we went in here in the first place. It gets even, you might say, it's no problem. All I do is I subtract 1 and I've got my answer. It works perfectly fine until somebody comes along and says, okay, there were absolutely no tests. And currently it does say that the test count is still 1 because we actually ended up in a loop. This is, although it's possible to do this and compensate for things, there's going to be a lot of cases where it just doesn't work in general. Okay, so just Sentinel-based loops, if you're dealing with user input, it's an input just before, it's an input at the end. In other cases, if you're dealing with searching through a list of things, it's actually pretty similar. Okay, sometimes you can get away with it, sometimes you can't. Okay, and you might say, well, fine, I'll just subtract 1. I don't know. I mean, test count should actually represent the number of tests, always, not just after I've adjusted 1. It shouldn't be the number of tests plus 1. It should be actually the number of tests. All right, but in any case, as I said, just watch out because that is sort of the standard approach is an input just before, an input just at the end. It's the typical thing. All right, next. What are we doing? Okay, yeah, we're going along. Don't worry for time. It's not too bad. We've got lots of stuff. I can rush through some things. What's coming next? Oh, okay, well, that's cool. All right, here we go. I decided I was going to include these. Sometimes the other instructors are like, no, we shouldn't show them these. But I think it's legit. Okay, I think it's completely legit. There's 2 items which I would call flow interrupters for loops. The first one is called a break, which causes the loop to currently stop whatever it's doing. Remember what I said, once somebody inputs something, or once you enter the loop, the entire body executes. Break is a way to get out of that. Continue is another way to get out of it. It all has to do with wherever you're going. Some people say, no, never touch them. But sometimes it ends up really cleaning up your code quite a bit. And I think what I will do is just for the convenience of time, I won't do this for many, but I will copy and paste this one. Okay. Usually I will type absolutely everything, but for this one, we'll push this in. I'll type the next one. All right. So we've got ourselves a program. Okay, first thing I'm going to ask is, based on the two types, is this a sentinel-based loop or a counted loop?
Count.
Yeah, it's counted because you can see something called test number is less than something, and you can see test number plus 1. You'll notice where I always put my increment for the counter, very last item. Okay, I always do this because if you forget it, that's the first place that you look. If you get an infinite loop, you look at the end and you go, how come it didn't increment? And it's usually because somebody's forgotten something. All right, so we've got this. If you ignore those two statements right there, really? There we go. If you ignore those two statements, that's nothing new. We just saw this one a few minutes ago. It goes through a total of 5 times, counting the number of passes. It also counts the test numbers, so I would actually have that at the end if I need it. All right, but here we go. I now have a couple of extra if statements that I've tossed in. Take a look at the statement on line number 6. All right, the statement says if the score is equal to -1, I do a print statement. Okay, that's pretty straightforward. In fact, Java updater, no, go away. This is not the time to do it. Let me comment these out for a second. Okay, at the moment, all that I'm doing is I'm typing in values. If somebody types a -1, it just says stopping the program early. Of course, it doesn't do anything, but it does continue. Well, it's complaining about some invalid stuff because it's outside the range. That's perfectly fine, but the program just continues. Okay, all right, let's pop up the first one, break. What a break does, a break will immediately terminate the entire loop. It won't go back, it won't check the condition to see whether or not the condition is true. It just immediately stops the entire loop. It doesn't stop the program, but it will continue on with the rest of the program. So most programs will probably have like many lines afterwards, but this loop completely goes away. So take a look at this. When I run this application, okay, we put in some valid data, this number, 12 is certainly a valid number. If I put in a -1, take a look at what happens. The program immediately stopped. It printed the message that the program stopped early, which we had a second ago, but you'll notice what happened is it didn't ask me for test number 5. It just gave up at 4 and said, that's it. It still ran the rest of the program. It didn't crash the program. It just stopped the loop. Sometimes this is something that you want. Okay, so we provided the ability for the user in this case to basically get yourself out because, well, you started something. And so right away it's just like, oh, I didn't want to run this program. Okay, you know what, -1, I'm out. I mean, it still produces a result. It just like, okay, we're finished. And sometimes you want that. You actually start something, you say, no, forget it. All right, that's the first word. So the word break means stop the loop, get out, continue with the rest of the program. There's another word as well, which now we will on comment, called continue. Okay, continue is kind of the same as a break, but a little bit different. When you hit a continue, the current body of the loop is skipped. Okay, obviously you can't go back and undo things, but what will happen is if you ever hit continue, the items right here will not execute. Okay, just like a break. But instead of going after the loop, it goes back up to the top and it checks the condition and it continues. Take a look at the difference. Okay, we enter a value like 70. Perfectly fine. Nothing is different. The test number obviously went up by 1 because it's now showing test score 2. If I put in something that's outside of the range, for as an example, like 600, nobody's getting 600 on their midterm. Okay, that'd be quite a bit of extra. Take a look at what happens. Because it's bigger than 100, well then it's definitely going to say score is invalid. Okay. But take a look at the test number. The test number is still 2. Why? Well, because when it hits continue, it jumps from here and it goes back and it says, is the test number less than 5? If it is, then do this stuff, just like we did before. It does not do this because I said continue. So this is very, very handy sometimes if you need to skip over a bunch of other stuff. And it's very, I'm going to call it as controversial. Why? Okay, if you think about the flow chart, I know nobody wants to think about flow charts. If you think about a flow chart, we're talking about sticking an extra diamond in the middle of a while body loop, and it goes back up and got another one that jumps out. People who really like flowcharts absolutely can't stand this stuff because well, it's hard to draw. Okay, but let's be honest, how many people draw flowcharts? Okay, so they're okay. You have to be kind of careful about using them because it can make your programs very difficult to read. But in a lot of cases, it does actually help. To be able to do the same thing here without a break and continue, it's possible. But I think the logic would be really kind of unpleasant. I would end up having to start with a check to find out if it's not equal to 1 and the score is this and not this and that. It's possible to do. Okay, it's possible to do. It's just the conditions become really, really difficult. Do I use them? Yeah. Do I use them all the time? If I need them. I don't use the continue very often. The break is very helpful. This is what I find. Continues, not so much, but they're here if you ever need it. Okay. Now, the code, any code that I ever give you for programming, it will never say you must use a break or continue. I'll never do that. I'll simply say, write this code to solve this problem. If you want to use a break or continue, okay, sort of tread carefully. Usually I don't give you problems that would absolutely require it. In fact, we don't need it so often here. You can always check with your lab instructor if it's a regular exercise to find out, is this okay? Because they're the ones who have to look at it, and maybe they've got a very strong opinion to say, no, you will never use break or continue. And if they give you those instructions, you have to follow them. I mean, it's okay if I'm grading your stuff, but I'm not. So just be cautious about this. And of course, the great thing is yeah, you type in a bunch of random values, it never increments the test score counter. You'd have to enter 5 valid numbers, well, in the correct range in order to actually get the program finished. So there we go. It's just something new. Yeah, there could easily be MCQs about this. All right, next one. Well, we had one of these earlier. It's an infinite loop. Whoops. Those are loops that just never stop. Are they good? In certain contexts, they are. Okay. When you power up your computer, how long does it run? Until you turn it off. Okay, that's an infinite loop. Yeah, the operating system has an infinite loop in it. Yeah, sometimes they are useful. For most of our programs we write, no, they're probably not useful. But if you're writing servers or other things, yeah, there is actually some purpose. However, sometimes I find it useful to write an infinite loop. That sounds really strange. Why would I ever write an infinite loop on purpose? I write infinite loops because I don't know the condition. Sometimes I just don't know what the condition should be yet, and you've seen how I write the code. I don't just write from top to bottom and hope everything is correct. Sometimes I just get a loop started, and then I figure out what to put in later. Like case in point, sometimes I will write code, literally, that looks like this. Whoa, not like that. Here we go. Okay, so watch this. While true. That's an infinite loop, by the way, because the condition is always true. And I will do things like this. Test score is equal to int input enter test score, blah, 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 blah. Okay, more shortcut. Here we go, and I'm just going to print something about test score. So I'll just say if test score is bigger than or equal to 60, we'll print a pass. Otherwise, we'll print a fail. Okay, it's really just sort of like quick checking, like, okay, is this type of stuff working? When does my program finish? Well, it never does. Okay, this still had purpose because at least it got me a chance to start on something. Okay, and then of course I'll figure out, okay, how am I going to stop this program? That's what I use it for. But there's other legitimate things as well. The one place that you can use this, it says in the very last bullet point, if the bullets ever show up again. Here we go. The very last bullet point kind of makes a case for it. It says you can escape an infinite loop with a break. Okay. An infinite loop with a break. Okay, perfect. So if test score is equal to -1, break. Okay, so what have I got? Oh, I got an infinite loop. Oh, not like that. Here we go. I've got an infinite loop. No, actually, I've got a sentinel-based loop without having to use 2 input statements. Does it make your code cleaner all the time? Sometimes. Sometimes it makes it messier. Honestly, you should know both ways. Don't just pick one and say, yeah, I'm always going to... Make sure you know both ways, okay? Because sometimes you have to trace things. sometimes the condition to stop the program is so difficult that you don't want to put it here, but you want to split it across multiple if statements. That's the place where I end up using these breaks most often. Okay, what else have I got in here? All right, so here we go. Here's an infinite loop, exactly the one that I just put in. I just set up an infinite loop with a true, and if the score is equal to -1, then I cut myself out. It just made the program maybe a little bit easier. All right, so we've got, how are we doing for time? 3 o'clock. All right, I've definitely got 10 more minutes, and I've got 2 slides. Perfect. I can manage probably 5 minutes per slide, especially if, no, I got 3 more slides. 3 minutes? Okay, we'll see. We'll see. In order to deal with this, what I'm going to do is, let's write a little program. Okay, I'll copy and paste I'll write this one, I'll copy and paste the next 2 because I think the next 2, I'm trying to decide which ones. Okay, here we go. I'll copy and paste this one, maybe I'll type the next one. All right, here we go. This is a program. Okay, so here we go. Let's leave a comment up here so that it's written down. All right, so have the user enter, question mark, bills. How many? You should be able to read this. What's the code doing? This is a case of, here's the answer, what's the question? How many? No, it's not infinite. The numbers are here. Yeah, it's 5, right? Bill number is equal to 0. Bill number is less than 5. Bill number is bill number plus 1 at the bottom. It's a standard counted loop. Okay, have the user enter 5 bills and compute the total. You can actually see it right here. The total is the total of all the bills. Okay, it's a summation pattern. All right, we quite often have to do this where you have to sum up a bunch of stuff. It happens all the time. And you might not just say, okay, it's about calculating averages. Yes, that is certainly true. It's not just about totals for bills. You see, even like this web browser, yeah, you need to count up the total amount of spot. Because if you wanted to put this button into the browser, you need to know the height of this piece right here. You need to know the height of this piece right here and everything else that shows up in the page before it. And that will tell you where the location is for the starting location for the button. So browsers even need to do it. All right, so what happens? Okay, yes, we can see it's got the regular pattern. So here you go. It's this, this, and this. That's the counted loop pattern. I've also got a total is equal to something, kind of like what I was doing over here, but instead of putting up the total by 1 each time, I'm putting it up by the amount that was entered. So if I run this, what's the value of total right now before I type anything? It's 0. It's initialized on line number 5. All right, I'm about to type in a value, so I'm going to say 12. And what's going to happen? Well, the bill amount's going to be 12, and total is going to be 0 plus 12, which is 12. Okay, good. So we'll press enter. That's the value of total. All right. To keep this as simple as possible because otherwise I'll have difficulty doing the addition. All right, here, we'll make it 2. All right, the value of total is currently 12. All right, we are about to add 2 to it. What does the value of total become? 14. Well, but you can't see it. Yeah, well, it's because we're not printing it. But what's happening is I'm accumulating a value. So now it becomes 15. Now it becomes 20, and now it would become 30, and there you go, there's the answer. By the way how you figure out these things is don't be afraid, don't be ashamed to do this. If you're having some problems and things are just not working, print it out. Okay, for example, if I put in 34, total is currently 34. If I had a 12, it should become 46, and yeah, that's exactly what it is. And if you're having problems and you can't see what's inside, don't wait till the end. Yeah, sticking a print statement wherever you want, it's completely fine. You know how often I use print statements for figuring out what's going on? All the time. If you're afraid saying, yeah, but I don't want to do that, well, this is not the way how you're going to write or you're going to learn how to deal with programming. Use print statements. In later courses, you'll learn how to use a really cool concept called a debugger, but for here, all we have is print statements. All right, so you can see what's going on as it's happening. So if I add another 10, what do I get? 56. All right, if I put in a minus 10, yeah, it actually goes back, and if I put a minus 46, it goes back to 0, and I suppose maybe it could be represented as a discount, or maybe that should be just an error and we shouldn't allow it. That depends on the problem. All right, so that's the summation pattern. That one I know is covered in 1101. Here we go to the next one. All right, the next one up is, okay, what comes afterwards? Input validation I could care less about. This one's probably more important. All right, have the user enter 5 bills and compute the total of all the bills. We'll assume that nobody's going to put in negative values because that's really nasty. Okay. All right, there we go. Pretty simple. Show the largest bill value. Okay. So in other words, out of all of these bills, what's the biggest number? 34, not 46, that's really small. Let's pretend that nobody's putting in bad numbers, okay? So nothing below 0, it's, or even below 1, because it wouldn't make any sense. Okay, so how do we deal with this? All right, there's always a very, very standard pattern that's used for finding the smallest of something, or the biggest of something. It works almost the same way. And again, I did suggest to the people running 1101, I said, do they see this? And I got mixed answers. But in any case, regardless of whatever it is, I'm going to do a very simple one. I'm going to leave the more complicated one on the slide for you to look at. Okay, but it always works like this. What I have is I have a variable called largest. Okay, I'm going to call it largest bill. All right, what's the biggest bill we've seen so far when we reach line number 5? Well, we haven't seen any. Okay, so here's what I'm going to do. I'm just going to put as -1. You can actually initialize this to be almost anything, as long as people aren't typing in negative values, but I'm just going to initialize it to be -1 because that's an indication to say the program hasn't even started. Because what I'm going to do is as soon as the bill amount comes in, I'm going to start asking questions, and I'm going to say if the, let's get it over here, if the bill amount is bigger than the largest bill, what I'm going to do is the largest bill is going to become the bill amount. Okay? All right. Let's do some more printing. Total and largest bill, because I want to see what these things are. All right, so here's what's going to happen. I'm going to run the program. Okay, first bill comes, or first item comes in, it's 45. I'm going to ask the question, is 45 bigger than the largest bill? And the answer is yes, because right now the bill is, or the largest is -1. That's going to be bigger, so what it should do is it should replace it. The total is going to become the old total, which was 0 plus 45. And the result is, yeah, they're both 45. All right, the next item is 10. Is 10 bigger than the largest thing we've ever seen? And the answer is no. So this if statement right here is going to be skipped. This, on the other hand, is still going to execute. So the total goes up by 10, but in terms of the largest still stays at 45. That's the second number. All right, and it continues on this way. So if we have, say, 125, that would replace the largest. Of course, the sum still continues to go up. And if we have like a 10 item, it also doesn't change, in a 5 item, that's it. So the total of all bills is 195. I forgot to print the largest, but you can see it's right here inside that variable. Okay, so sorry, one extra print statement, we'd be okay. Now, I did something a little bit different on the slides. I did something a little bit more complicated because I wanted to have kind of as much stuff as possible. Okay, I can blame this on running the Kahoot. All right, and this will be our final thing. I will talk about this, and I promise with less than 5 minutes we'll be done. All right, this is the same program with one extra feature. Not only did I include a bill, the largest bill, I also included the largest bill number. The number of the largest bill. So remember, bill number 1, bill number 2, bill number 3, this type of thing. So take a look at what I'm doing here is I initialize this to be 0. Oh, okay, -1. You know what, as long as you pick a number that's less than all the other bills, it'll be perfectly fine. If I put the largest bill was 10, it'll ignore anything that's small. That's the problem. And if I allow for negative values for bill numbers, then the whole thing becomes a real mess. Because the largest bill might actually be a negative value and it would end up failing. I suppose we could try that. Okay, so there, I'm answering the question that nobody asked. All right, so minus 60, minus 20, oh, sorry. We also need to print the largest bill at the very end, okay? So, yes, I would normally put a message around that. All right, so here we go, minus 30, minus 10, minus 4, minus 900, and minus 123. Okay, out of all of these numbers, which was the biggest?
-1.
Minus 4 was the biggest. Unfortunately, it does say -1 because when we initialized this, we said, well, this is the biggest. So in other words, if you wanted to deal with negative values, there's a couple of things how you can, or a couple of ways how to do it. I'm out of time, so I'm not going to be able to do too many of these, but that's one way of doing it. As long as everybody enters bills that are bigger than this number, it will work. A better way is to initialize it to the very first number that's entered. Okay, that's a better way. You'll probably see that in the lab. All right, let's get back over to here for a second. Okay, so this is the one I said I was going to finish. All right, so not only am I going to keep track of the largest bill, I'm also going to know which number it was. Notice that all that I've done is if the bill number is bigger than the largest bill, I replace the largest bill with the bill amount. I just did that. And I also record the bill number that it just came in as. So I have two things. Yeah, two separate variables. Everything else is exactly the same. Okay, and I suppose what I should do is let's copy this just in case it fails so that at least I can fix it. Okay, again, negative values, not going to work. All right, 45, 13, 57, 12, and 5. Okay, which one is the biggest? 57. Which bill number was the biggest? Number 3 was the biggest. Okay, I don't mean what was the amount of the number of the bill with the biggest number. I'm talking about the quantity. All right, so yes, it does come back and it says the largest bill was bill number 3 with a value 57. So if you need to know both the value and the location where it was, well, it's second variable. Okay, and yeah, they both get updated at the same time. All right, so there we go. That is. It's essentially the slides that I wanted to make sure that was finished. There's one final slide over here called input validation, which I'm just going to do a very quick little description of it, and I promise I have to be finished. You see what I've done here is from here to here, that's a sentinel loop. It's got an input just before a while. It's got an input just at the very end. And what I'm doing is I'm saying, okay, if somebody enters something and it's not digits, then I complain and say, sorry, you can only enter digits. And then I ask again, and notice that if I continue to type bad values, I'm kind of stuck in a loop. I suppose what I could do is I could just run it once, and I'll leave this for you to go through. Stop it, wrong place, paste. I've got an extra C for some reason. No, enter digits. All right, here's some digits, here's some digits. Yeah. Stop it. Stop it. So what's happening is when I'm typing in these bad values, I'm basically stuck in this sentinel loop right here. So it's a combination of the sentinel loop inside to do validation with a counted loop outside to make sure I'm getting exactly 5 scores. Okay. All right. So that's the process. Now, if I had a little bit more time, well, then I would run that little Kahoot. But since I'm out, I'll use the Kahoot only at the beginning of next class and probably run out of time again for that too. So now we've got ourselves a pattern. This happens at the beginning of the loop body. Repeat every time, and it's always based on the previous.
It stops after 5 or not.
And this still stops after 5, yeah. So here we go. Oh. Here we go. And one more. There we go. It is finished. All right, so when does the horrible pattern of this lecture finish? Well, I don't know how many more we've got, but we could certainly count because we know in advance how many lectures we've got.